Assalamu alaikum. Okay, we have a question on erratic motion. We have been given the VT graph of a car while traveling along a road, and we have been asked to find the ST graph, the position time, and the AT graph for the motion. Okay, here I'm going to divide my graph into segments, number 1, 2, and 3. Okay, and also I'm going to remind you what is the equation of a linear curve. The general form is y equal mx plus b, where m here is the slope and b here is the y intercept. Okay, for the first segment here, what do we have? I would like to find the velocity here, simply using the general shape of the linear curve. V will be the slope. The slope here will be the rise over the run. So it's 20 over 5 t, and the y-intercept is 0. So just that will be my first segment. Okay. Now from here, since I'm going to draw the ST and AT curve, let me find both S and T in this interval. To start with, let me find S. Here, S can be found, of course, I'm going to use the kinematics relation, in which V is equal ds over dt, and A equal dV over dt. Okay, so now for the S here, I'm going to integrate both sides. So I have ds equal the integration of V dt. And how we have to be careful about the integration limits. For the S here, I'm starting from 0, so from 0 to any position within the first interval, to S. And for the time here, I'm also starting from 0 to any time within the interval. So now, substituting everything here, we have S will be equal the integration of 4t squared, 4t here. I will have S to be 2t squared. Okay, so now we have S. What about the A? Of course, A, now we can find the derivative for this curve for V. So you got A to be just 4. Okay, so now we have these two results for the V, for the S and the A. Okay, for the second segment, V simply here is constant. So V is constant, and how much is that? It's simply 20. So V is 20. Okay, and now we can find S, ds equals the integration also of V dt. Now you have to be very careful about the limits. One more time. Now here, what will be S? What will be the lower limit here, and what will be the upper limit? Okay, the upper limit, we just want to find this, for any S within the interval, so just S, and for V, for any V within the interval. Now for the lower limit here, for the S, how can we find that? Now you have to use the result we have obtained before. So let me call this as result number 1. Okay, so now what is S here? S here for the lower limit for the second interval will be, S at time of 5. So in other words, now here, S at 5 would be what? Will be 2 times 5 squared, right? So it will be 50. Okay, so now that's my lower limit, 50. And what about the time? The time simply is 5, because we are starting from 5. Okay, so now finding or doing this simple integration, you will get S minus 50 equal this V here. We got V to be 20, right? So this is here 20. So 20 V minus 5. And just rearranging this equation, you will solve for s, and now s will be 20t minus 5. So that's the second position for the second segment. Now immediately we can find a as well from the v equation. A will be 0 because v is constant, so that's the a. Okay, for the third segment, what do we have? Now I have the slope for this segment, segment number 3, I have the slope to be negative because I'm going down. And how much I'm going down? You know, I'm going down 20, and I am running from 20 to 30, so 10. So the slope for this segment will be, so v here will be, what will be minus 20 over 10 t plus the y-intercept. Now I don't know that, let me just write c. How can I find this c? Now we can substitute what will be v at 20, because v at 30 is 0. So these are the only 2 points I know between this interval. So I can say v at 20 seconds is equal to 20, right? I know this. So here I have 20 equals to minus 2 times 20 plus c. And solving that for c, we'll get c to be 60. So the velocity in this interval will be minus 2t plus 60. Okay, the same, I can find the acceleration. A will be just minus 2, just the derivative. And now the displacement, or the position, integration of ds equal the integration of this minus 2t plus 60 dt. We have to be careful about the limits of both integrals. Here the upper limit for this will be v, and the upper limit for the s will be just s. Okay. Now the lower limit for the position can be found by substituting what? 20 in place of t here. So s here will be 20 times 20, right, minus 5. I think this is there's a mistake here. This should be, yeah, this should be 50, right? Yeah, this should be 50. So minus 50. So it will be 400 minus 50, so 350. And for the time here, I'm starting my third segment from 20. Okay, so doing this, we'll get s minus 350 equals, and now substitute the other side. I mean the upper limits after doing the integration will be equal minus t squared plus 60t, right, from 20 to v. So now just rearrange the equation. I got s to be minus t squared plus 60t minus 450. So that's my s. Okay. Now what about the a? You know, we have found a before to be negative 2, just the derivative of the velocity function. Okay, so now we can draw our st and at graph since we have all the functions. Let me start by the st. That's the s and the t. The first segment here, what do we have? We have s to be 2t squared. So since it's a positive, I mean the leading term here, the leading power is positive, it's a quadratic function, so it will be concaved up, something like this. Okay. Now for the second interval, I have a linear curve. So s is just 20t minus 50. So it is something like this. Okay. And the third segment, I have s to be the leading power here in this quadratic term is negative. I mean the sign of that, so it will be somewhat concave down. Okay, and now these are the intervals. From here to there it is 5, and from here to there is 20, and here it is 30. Okay, so that's it for the ST. Okay, now for the AT graph, what do we have? AT. The first acceleration we got for the first segment was 4. So just 4 meter per second square. Okay, so I got here this to be simply 4. And you know, this is the interval at 5 seconds. Then now, here you have to look at the second interval, which is simply we got 0. So for the second interval, simply the acceleration will be 0. So during this time interval, up to 20 seconds, I have no acceleration. The third and the final segment, we got A to be minus 2 meter per second square. So now I'm going to go a little bit down here, the curve, and that is my acceleration. Okay, constant. We just have some space here. I got negative, and that is the time interval of 30 seconds. Okay, so here is 4, and here is negative 2. Okay, thank you, and I hope you found this video useful. Please like and share the video, and let us know in the comments if you have any question or suggestions. Thank you very much, and wishing you a good luck.